And we have seen the bioxidation of alkyl side chain. We can prepare carboxylic acid. And next method we have seen through Grignard. Okay, we can prepare the carboxylic acid. So you need to check first of all how many carbon atoms are there. Are the carbon atoms same or different? Okay. Accordingly, you should choose your pathway to carry out the reaction. So as we have seen, if more carbon atoms are there, okay, so we have seen that you can oxidize alkenes and get the carboxylic acids by acidified potassium permanganate. That's what we had seen. You can oxidize the alkene, you can oxidize the primary alcohol that we have seen. But if you want to increase the carbon atoms, you either need to add KCN or you need to add CO2 in the Grignard reagent. Okay, then you will get the product. Clear? And we have seen how to get aromatic carboxylic acids. Either you can hydrolyze the trihalides or you can oxidize the side chain. Okay, aromatic side chain. But this method is applicable only for ring which is present outside the benzene. Is it clear or not? Not on the normal aliphatic compounds. Okay. So, and the questions will not be related only to carboxylic acids. Okay. They will include the concepts of alcohols. They will include the concepts of aldehyde ketones. Okay. So let's do one problem where you are asked to convert acetic acid to propanoic acid. How are we going to do this or achieve this conversion? Acetic acid to propanoic acid.
Using KMNO4.
KMNO4 will oxidize primary alcohol to carboxylic acid, and the carboxylic acid is already oxidized. So it will not get oxidized further. You need to increase, are the carbon atoms same or more? Definitely they are more, you can see. That there is increase of one carbon atom in the form of COH. So either, so first we need to put that extra carbon. Okay, and that once you put that extra carbon, then you can oxidize that carbon to carboxylic acid. Is that clear? Any doubts on this? So, but the doubts will come when you will choose the reagents. So what I want to you to is choose the reagent KMnO4 will be used, Aisha, but in the later stages, not in the initial stage. Got it?
Yes, sir.
And this reaction is going to be a very important reaction because it involves the concept of all the previous chapters. Alcohol chapter, alkyl halide chapter, and carboxylic acids. So first, we need to put KCN or Grignard. Is it clear? So what I will do is, first I will reduce it using NH. When I reduce it using LiLH4, this is going to change to CH3, CH2OH. Right? This is the reduction of carboxylic acids. And the preparation of alcohols we have seen using LiLH4. You can't use any BH4, that also we had seen because that was mild. Got it?
Yes, sir.
Okay, now what to do? Once you have this OH, can we oxidize it with KMnO4? And get it converted back to COOH? Will that give the desired product? Tell me quickly.
We'll use an
What we will
alkyl group.
Yeah, actually we need to increase the carbon atoms. We can't go for direct oxidation, otherwise if we go for direct oxidation, we are going to end up with carboxylic acid back. That we will not do. Yeah, we need to add some carbon atom. So what you can do is make it halogen, okay, because alcohols are difficult to displace. How you will convert it to halogen by using SOCl2. You can use PBr3 also. Okay, lot of methods we have seen. SOCl2, PBr3, got it? PCl5. SOCl2 was one of the best method to get Cl. Okay, if you remember. Cl. Okay. Now we can get it converted. Either you can use KCN or you can get it converted to Grignard by heating it with Mg in the presence of ether. And this is going to give CH3, CH2, Mg. Now, once we get Grignard, what we should do to increase the carbon atom? We need to add CO2. COOH is there, no? So add CO2 and H plus. Is it clear? So first add CO2, then do the hydrolysis. That will convert that CO minus to COH, and you are going to get this product. Is it clear or not?
Yes, sir.
Okay. Or you could have used KCN and hydrolysis. use KCN. This will become CSC CH2C. So you have that extra carbon, you need to hydrolyze it with excess of water. That CN will get hydrolyzed to COOH. Clear?
Yes.
Yes, sir.
So this is important conversion, and they're asked everywhere, right? Be careful about it. Okay. This is the preparation of a carboxylic acid which is having more number of carbon atoms. Okay, step up reaction. That means more number of carbon atoms we are having. So make sure that you add something which contain that extra carbon. Okay. Similarly, there are ways by which you can decrease the carbon atoms also. And you need to cut it off. You need to remove the carbon atom. Okay. So the next question which I'm going to ask, this is also very, very important. Basic question, okay, and a lot of reaction you can see are being covered. If I give you propanoic acid, which is having 3 carbon atom, and I ask you to convert it into ethanoic acid. Clear?
Yes.
So how we are going to achieve that?
A base, like,
So what we can do is, this is CH2H, COOH, sorry. This is carboxylic acid to carboxylic acid, but with lesser number of carboxylates, carbon atom in the final carboxylic acid. So this is going to be a step down reaction, okay, where you need to decrease the number of carbon atoms. So let's see how it can happen. First, reduce the carboxylic acid by using lithium aluminum hydride. Okay. What are we going to get? What are we going to get? LH will give convert the carboxylic acid to primary alcohol. Primary alcohol again when they get oxidized by acidified potassium permanganate, they change to carboxylic acid. Okay, that was oxidation. This is reduction. Is that clear? But how it will help us to decrease the number of carbon atoms? Okay, that we need to is yet to be worked. Okay, so what we do, we can take concentrated H2SO4. what concentrated H2SO4 will do on alcohol? Hmm? Tell me quickly. Concentrated H2SO4 we have seen in the alcohol chapter. Hmm. Concentrated H2SO4 will cause dehydration of alcohol. Got it? Removal of water. Is it clear? Marwa, Aisha, Jasleen, is it clear or not?
Yes, sir.
So what are we going to get? We are going to get propane. Aisha, is it clear?
Yes.
But how we're going to get the carboxylic acid? You can cut it. Okay. Using acidified potassium permanganate. Acidified potassium permanganate not only oxidizes the primary alcohol to carboxylic acid, it also breaks the double bond. Oxidatively cleave that double bond. And this part is going to end up with, okay, and this part is going to get oxidized as CO. Is this clear or not?
Yes, sir.
Okay. So these are the methods to increase the carbon atom and decrease the carbon atom. Step up of carboxylic acid and step down of carboxylic acids. Got it?
Yes.
Okay, next method. Preparation of carboxylic acid from aldehyde and ketone. Okay. Aldehyde and ketones. Okay, but aldehyde it is very easy. So how the aldehydes can be oxidized to carboxylic acid?
Oxidation.
Now any oxidizing agent will do. Okay, even the toluenes, spellings reagent can also oxidize it. Is it clear? That's what we have seen in the test of aldehydes and ketones. Got it? Is it clear or not? Okay. So any uh, any oxidizing agent, even the KMNO4, A2CR207, AgNH3 whole twice plus, that also can be used. Okay. And you are going to end up with acetic acid. Clear? But the oxidation of ketones, does that happen under normal condition? So my First question is, do ketones get oxidized under normal condition? What's your default answer should be?
No.
Yes or no? Hmm. Ketones
They
do
cannot
not,
get.
they do not get oxidized under normal condition. Okay, no oxidation. Why? And this should be your default answer. Okay. Is it clear?
Yes.
But if you oxidize it under vigorous condition, okay, using concentrated HNO3 heat, okay, long time, okay. So how the ketone should get oxidized? That's what the question is. Normally, do ketones get oxidized? No. Okay, this should be your answer. Ketones do not undergo normal oxidation. Okay. They can undergo oxidation under vigorous condition. But they get oxidized under vigorous conditions. Got it? With the strong oxidizing agents. So vigorous oxidizing, strong oxidizing agent, they get oxidized. But how will they get oxidized? Is option A or option B? Oxidation splits them into two carboxylic acid groups. Is it clear or not? Vigorous condition, strong oxidizing agent like concentrated HNO3, KMNO4, it splits, the ketone splits into two parts. I'm asking you, how it is going to get splitted? I have drawn two lines showing you two options in which the ketone should be cut into two halves or two carboxylic acids. Is it the option A or option B? Okay. Deslin and Aisha, Marwa, are you getting my point?
Yes.
What I am asking?
Yes.
So the answer is Ketones get oxidized by Popov's rule. Okay, what that rule says? The rule says that while breaking the ketone during its oxidation, the CO group, C double bond O group, must go along with the smaller alkyl group. Got it? CO goes with the smaller alkyl group. Is it clear or not?
Yes, sir.
CO goes with a smaller alkyl group. So by which line we should cut along the A or B to get the final product of oxidation of the given ketone? Should I cut it along A? Should I cut it along B? You can see the two demarcations. Marwa, can you see them?
Yes, sir.
So which is correct? Read this statement.
Yes. Yes, sir.
Oh. So we should cut it along A because CO is goes with a smaller alkyl group. Got it? Clear?
Yes.
This is the Popov's rule. Okay, do remember it. Very important. So if I cut it along A, I will get 2 carboxylic acid upon vigorous oxidation. That is only under vigorous oxidation, not under normal oxidation. Under normal oxidation, what will you say? You will say ketone do not get oxidized. Got it?
Yes, sir.
Only under vigorous conditions. And this is the left part is acetic acid because the CO has gone with the methyl because that was the smaller alkyl group. And this the right alkyl group that also will get oxidized to carboxylic acid. Is it clear or not?
Yes, sir.
So Popov's rule. But if it is a symmetrical ketone or cyclic ketone, then you don't have to bother much. Suppose how this is going to break. So how it is going to break? Like this, and this cyclic chain is going to open up. Okay. So that upper carbon is going to become carboxylic acid. There are 6 carbon atoms. Keep a track on the number of carbon atom always while doing your questions. Okay. Got it? So you are going to have hexane 1,6-dioic acid. So this I hope is clear. Okay. So let's move on to the other method. Other method for the preparation of carboxylic acid is by carrying out the hydrolysis of carboxylic acid derivatives. From carboxylic acid derivatives. By carrying out their hydrolysis in acidic or basic medium. Got it? Clear or not? So how many carboxylic acid derivatives are there? And these carboxylic acid derivatives are formed when the water is removed. Okay. When you put water, these carboxylic acid derivatives undergo hydrolysis and give the carboxylic acid again. Got it? So what all carboxylic acid derivatives we are having? We are having 4 different carboxylic acid derivatives. The first one is acid chloride. Okay, carboxylic acid chloride, which I can generally write it in this way. Here. So you are going to use H and OH. You are going to use water to carry out their hydrolysis. Is it clear? But simple water is too slow to do the reaction. The reaction is not going to be very fast with simply taking water. So what you do is you take some acid or base along with it. Got it? Base catalyzed hydrolysis. And base catalyzed hydrolysis, that carboxylic acid is going to change to sodium salt. And here you can take water along with the acid. And if it is acidic medium, you are going to get the carboxylic acid.
So the Na is from NaOH?
Yes, NaOH or KOH, or if I can write it like this. So sometimes this is not written, sometimes the directly carboxylic acid is written, or sometimes one more step is mentioned in which you put H plus and change them to carboxylic acid. If NaOH or KOH is mentioned, just write them. If they are not mentioned, simply OH minus, so let it be O minus. Got it?
Yes.
And in this case, I have taken acidic medium. So both for acid, the carboxylic acid is also going to get, you are going to get as acid, and HCl also you are going to get as acid. Got it? Next carboxylic acid derivative is anhydride. Okay, carboxylic acid anhydride. In anhydride, you are having two carboxylic acid. Actually, anhydride means that two carboxylic acid are joined together by the removal of water. And if you put water again, it will break and they will again give you the corresponding carboxylic acids. Those two carboxylic acid may be same or may be different from one another. That depends upon the anhydride. What two parts are present in the anhydride? Got it? So let's say suppose if I have taken CH3, then H plus H2. Simply water will take long time, so you take H plus or OH minus as the catalyst, as I mentioned above also. So you can break this CO bond, put hydrogen on oxygen and OH on the other side of it. Clear? So when you do this, you get two carboxylic acids. Got it? But the molecule is answer is just one because both the parts are same. Only one type of carboxylic acid. What is the name of this anhydride? Can you name it? What is the name of this anhydride? Tell me.
A ketone.
No, this is not a ketone because you have
Uh,
oxygen.
Diketone.
Hmm?
Because diketone.
No, not diketo. Diketo is this one.
Oh, yeah.
Got it? This is diketo. Actually, you have anhydride. Okay, anhydrides are formed by removal of water from two carboxylic acids. Okay. And when you put water again, they will break again into their corresponding carboxylic acids. And the name also indicate the same. Anhydride means without water. So think of it, how it may have formed. How its formation, understanding of the formation of this will let us understand that what will happen if you put water into it. So When you heat it, the water, two carboxylic acid molecules react to get each with each other, and the water get removed by heating. And you get that anhydride. Got it?
Yes, sir.
Clear or not? And when you put water, in the above case, it breaks again into two carboxylic acid molecules. What's the name of the anhydride? Anhydride 2CO have O in the middle, that is the anhydride functional group. What is the name of this anhydride? The name is none other than the name of the carboxylic acid, parent carboxylic acid. But in parent carboxylic acid, we put OH, COOH, got it? Oic acid, got it? Is it clear? And so you put oic acid, but in the name of anhydride, you are writing the name up to oic, but you're not mentioning acid. Okay. So this was ethanoic acid. Let me write the actual name. This you already know, ethanoic acid. Got it. And this is ethanoic anhydride. Got it?
Yes.
Anhydride means without water. So I'm going to write the name up to ethanoic, but not acid. Instead of acid, I'm going to use the word anhydride because it is without water. It may not be necessary that. And what's the name of this acid chloride? That name also we can discuss because that is also part of NCRT. Okay. So what is the name of this acid
Acetyl.
chloride? Yeah, acetyl chloride, exactly. That is the common name, very common, equally important. Okay. Similar to IUPAC, but not IUPAC. Okay. Acetyl chloride, that is true. Absolutely correct. But the IUPAC name is oil. That suffix is oil. So ethanoyl chloride. Eth for two carbon atoms, ane for single bond, and oil, OYL chloride. This is the suffix for the acid chloride. The suffix for anhydride is oic anhydride. Got it? Is it clear? Because they are derived from corresponding oic acid, so you call them oic anhydride, and this is oil chloride. Got it? And in anhydrides, it may not be necessary that both the parent acids are same. We can have different parent acids also. Like suppose if you take CS3COH, so what is the name of the parent acids? What is the name of the parent acids? The left one has 2 carbon atoms, it is ethanoic. Okay, and the right one has 3 carbon atom, it is not anhydride, ethanoic acid, because till now it has not formed anhydride. It is prior to heating. They were acids, I am writing them as acids. And this is propanoic acid. Ethanoic acid and propanoic acid. These were the 2 acids. Now when you heat them with concentrated H2O, so what simply heat may be mentioned. Or acetic anhydride and heat, AC2O heat. Got it? Is it clear?
Yes.
So water will get removed. And these 2 acids which were separated now will join together through that oxy linkage and will become anhydride. Is this clear or not?
Yes, sir.
So what is the name of this anhydride? Just write the name of the parent acid up to OIC and don't put the acid and OIC and anhydride. Okay. So what will be the name of this anhydride? One was ethanoic acid. Okay. So we are going to use ethanoic. And the right part was propanoic acid. Okay, so we are going to put propanoic also. So ethanoic, Marwa, are you getting? Propanoic, anhydride. Okay, and this is an example of mixed acid anhydride. Getting my point?
Yes, sir.
Has everybody understood what is mixed acid anhydride?
Yes.
So are you going to get one carboxylic acid or 2 different carboxylic acids? That depend upon your anhydride itself. Okay. Whether it is anhydride made up of just one acid or both the parts same, then you are going to get just one carboxylic acid. Clear? 2 moles of that. But if you have 2 different parts, like the one which we have seen just now, you are going to get 2 different carboxylic acids. Okay, with the mixed anhydride, you are going to get 2 different carboxylic acids. Okay, this is the hydrolysis of anhydride. Okay, very easy. Now let me move to the other function group. That other function group which I'm going to discuss, carboxylic. It is a carboxylic acid derivative. You all are aware of that carboxylic acid derivative because of its fruity smell. Got it? So which carboxylic acid derivative that was? Tell me. Which has the fruity smell, you might be aware of that is of that carboxylic acid derivative. In from a class 10th, it has a very uh, good smell, fruity smell. Okay, that is carboxylic acid esters, or simply I can write them as esters. Is it clear?
Yes, sir.
So esters, how the esters look like? What is their structure? What they are made up of? They are carboxylic acid derivatives, so they are made up of carboxylic acid along with something. So what is that something? And if you do the hydrolysis, that carboxylic acid and something will get separated. Okay. So what is that something which is present along with the CO? Like in acid chloride, that CO is connected to Cl. In anhydride, it was connected to OCO. Yeah.
Alkyl groups,
Alkyl
two
group?
alkyl groups
No.
on both sides.
You have to, the CO, if you have two alkyl group, then it is a ketone. Hmm. You will have a ether like group or alcohol group, okay, on one side. So how esters are formed, first we can discuss that, okay. And how their hydrolysis will lead to the formation of carboxylic acids. One reaction I'm talking about, the forward formation of ester. The other reaction which I'm talking about is breaking of esters, hydrolysis of esters. Okay. So first of all, let me uh, explain how esters are formed. Because they are considered to be carboxylic acid derivative, means they are formed along with the carboxylic acid. When something get attached to the carboxylic acid, and what that something is that alcohol part. Okay. So when carboxylic acids are heated with alcohols, or with alcohols heated with carboxylic acid, okay, it is also serve as a test, laboratory test for identification of alcohols and carboxylic acids. Got it? Is it clear?
Yes.
When you heat them with concentrated H2SO4, water will get removed. OH and H. Okay. And you will get a product which is having a fruity smell. Esters having fruity smell. Got it? Water will get removed, and concentrated H2SO4 will help us to absorb water, because that doesn't have water in. Got it? Is it clear? So carboxylic acid, when heated with alcohols in the presence of few drops of concentrated H2SO4, you get a compound having fruity smell, and those are known as esters. Got it? Clear or not?
Yes.
And suppose if you put ample amount of water by taking dilute H2S, what dilute H2S will contain water and H plus also as a catalyst. What will happen? You can break them. Got it? As H and OH, you can separate them again. You will get carboxylic acid and alcohol. Got it? Clear?
Yes, sir.
So this is hydrolysis. Okay. And in what medium? Acidic or basic medium? So hydrolysis of esters is will give what all products are going to you are going to get when you hydrolyze esters. Getting my point or not? So are you going to get only carboxylic acids? It is one of the preparation of carboxylic acid. Got it? Are you going to get the carboxylic acids?
No, we
Or
have to like further acidify.
no yeah, carboxylic acid along with something else also you get. What is something
Yeah.
else? What is that something? So hydrolysis of ester will give you carboxylic acid and what is this? Alcohol molecule. Got it? Just hydrolysis of anhydrides give you two carboxylic acid molecules, carboxylic acid and a carboxylic acid. Got it? But if you hydrolyze esters, you get a carboxylic acid and a molecule of alcohol. Which alcohol? Not any alcohol. The alcohol which is there on that CO. You need to look at the structure of the ester very carefully. So ester can be formed by heating acids and alcohols together. Heating in the presence of acid will remove water from carboxylic acid and alcohol, and you are going to get an ester. If you take dilute acids, the esters are going to break into corresponding carboxylic acid and their corresponding alcohol. Is it clear? It is a reversible reaction. It can happen in both the directions. Got it? So how esters are named? Okay, the parent chain of the esters is this, the part which contains CO. Okay, you need to find the number of carbon atom in it. Accordingly, you should put the word root prop in O8. This is the suffix for esters, O8. Got it? Is it clear? Like the suffix for carboxylic acid was oic acid. The suffix for ester is O8. Got it? And the parent chain is the one which carries, because in this case we are having two groups. So most of the student get confused that which group should I take as the main. Getting my point or not? Is it clear? But that methyl is still missing. Okay, that is not the part of the main chain, it is put in the front. It is a substituent. Methyl propanoate. Is it clear or not?
Yes, sir.
Okay. So esters are named like this. So this is the parent chain and this is the substituent, okay, connected to that oxide. To remember it like this. So methyl propanoate, if we carry out the hydrolysis in acidic medium, what are the components which we are going to get from the hydrolysis of methyl propanoate?
CH3OH.
Yes, absolutely correct. That is the alcohol part. Just put H on O and OH on this side, okay, other side of the cut. Is this clear? And what is the other molecule which you are going to get?
CH3, CH2, C double bond O, OH.
Yeah, CH3, CH2, CO, OH. This is the, so we are going to get the corresponding carboxylic acid and the alcohol. They will get separated. Clear or not? Okay, so esters, they can be hydrolyzed in basic medium also. Is it clear? And it has a special name, base catalyzed hydrolysis of esters. Has a special name. Okay, the product will be just very much similar. What that hydrolysis process is known as. And we use in our daily life. A product, okay. In our daily life we use, which is made by this process. What is that thing? It is known as saponification. Got it?
Yes, sir.
Why such a name? What may be the reason for such a name? because this is used to prepare soaps. Got it? Base. So you take a long chain esters, okay, you hydrolyze them in the basic medium. So what we are going to get in this case? Or let's say if we have taken Na, we are going to get CH3, CH2, COONA, and CH3OH. Got it? So base catalyzed hydrolysis of esters is known as what?
Sir, can you repeat?
What esters can be hydrolyzed in acidic medium and in basic medium. Okay, when you break them in or hydrolyze them in basic medium, what that process is known as? What's the name of the process?
It's saponification, right?
Yeah, saponification, right? Got it. So it can be used for the preparation of sodium salts of carboxylic acids if they are long chain carboxylic acids, okay, and they will be called as soaps. Is it clear? Suppose if you have 18 carbon atom in this carbon chain, then you have that 18 carbon and CONA. That is known as sodium salt of the carboxylic acid or soap. Got it?
Yes.
We are going to come back to it in reactions or the preparation of carboxylic acid derivatives. Next is hydrolysis of amides. And nitriles. That also can give us these are amides. Okay. Alkanamide, butanamide, propanamide. Got it? Depending upon the number of carbon atoms in this parent chain, you can name the amides. These amides can be hydrolyzed in the presence of water with acid or base. Taken as catalyst. Got it? In acidic medium, it is going to form this ammonium salt and carboxylic acid, and in basic medium, what is the name of this amide I'm writing, which I'm writing? The amide which I'm writing now.
Methyl propane.
No, don't take ethyl separately and CO separately. Okay, take, because it is a principal function group. Consider the carbon atom of the chain and the principal functional group together. Got it? So now tell it. Prop in amide, propanamide. Clear or not?
Oh, okay, yeah. I finished.
Propanamide. Right. H2O means hydrolysis. Hydrolysis means, but I have used base as a catalyst. So I'm going to end up with this CH3, CH2, COONA. Got it? And NH3. In basic medium, you are going to get the not get the acid, but as the sodium salt of acid. This is the hydrolysis of amide. Similarly, you can hydrolyze the nitriles. The CN group, we have already used them in the conversion and we have hydrolyzed them. Okay. Hydrolysis of CN in excess amount of water. Okay. For example, this is CS3CN. Two more you use. Clear? Or they can be hydrolyzed in the basic medium also. But in basic medium, that CONA you will get. Okay, you need sometimes you can write COS also, that will also work. Got it? So this is all about the preparation of carboxylic acids. Okay. Now the properties, chemical properties and reactions. We can do some conversions first and then we can start with the chemical properties. Some conversions from NCRT only. Benzyl alcohol to phenyl ethanoic acid. How you are going to do this conversion? Hmm. So what is phenyl ethanoic acid? First, you are going to write the name of the parent chain, word root, and ethanoic acid. That is ethanoic acid. Okay. And this phenyl is a side chain. Got it? Clear or not? So, what is the structure of this? Ethanoic acid, you know, right, Aisha? Marwa, you know the ethanoic acid,
Yes.
and phenyl ethanoic acid is what it is. Just clean pH. Got it?
Yes,
Clear or not?
yes.
So this is phenyl ethanoic acid, and you need to get it from that benzyl alcohol, PHCH2. What you are going to do? So first, try to check the difference between the reactant and the product molecule. Don't straightforward start thinking that what could be the answer and what could be the answer. Okay, student, try to recall. That is of no use. First, try to check what's the difference. We are having this much of group. What we need extra? CO2. Okay, that CO2 can be added on Grignard. Okay, through Grignard reaction we can get CO2. But the problem is Grignard is not made by alcohols. It is made by alkyl halide, RMGX. So now the problem is to convert the OH to halide. So can you do that? The conversion of OH to halide? How we are going to do? Just now, yeah.
Associate. Associate.
Yeah, SOCl2, absolutely correct. Thionyl chloride, which is the best method to convert OH to chloride, or PCl5 or PCl3, or red phosphorus plus Br2. Okay, or PBr3 you can use. Okay, but this was the best method. Absolutely correct. So pH CH2Cl. Okay. Now we can convert it to Grignard. Got it. And then we can react it with CO2. NH plus. So you will get PHCH2COOH. Got it? Is this clear?
Yes, sir.
So,
So this is how we are going to get it converted. Okay. So this is one conversion, and another conversion is very easy. But the structures sometimes seem to be very complicated. But don't go by the complicacy of the structures, and you need to focus only on the function group. Okay. No need to bother about the extra structures, methyl group, ethyl group. Okay. They are just put. So 4-methyl acetophenone. Acetophenone is benzene COCH3. This is acetophenone. And on the fourth carbon you have CH3. Okay. And they are asking you to convert it into benzene 1,4 dicarboxylic acid. So how we are going to attain this conversion?
Blender condensation.
Hmm? This is very easy, just one step you need to do and you will get the product. What are we doing? This methyl is getting converted to carboxylic acid. Okay. And this COCH3 is also getting converted to carboxylic acids. So what we are doing, we are reducing, or what should I say? What word should I use? This is oxidation. Got it. And remember, we have studied that all the side chains get oxidized, right? Oxidized to what? Carboxylic acids. Just what remains upon oxidation of the alkyl side chain, what remains is just the COH. Okay. So this, I hope, is clear to all of you. Okay. So let's proceed with the chemical properties and chemical reactions in the next class, right? So let me in today's class. Okay. Bye bye everyone. Good night. Take care.